That's our H. So, hi everyone. My name is Clint. I like to start all my presentations with a very awkward photo of myself to kind of break the ice, and my name spelled very largely. That's mostly for vanity purposes, but also just to clarify that my name is not Glenn, Quint, Client, Chad, Quinn, or anything that ends in NT. Do I have any other Clints in the audience? No? If there was another Clint, he would know exactly what I'm talking about here. Whenever I call and order things, I have to spell my name, and my wife makes fun of me, but if I don't, I'm always Quinn or Client. I don't get that one either. So maybe you've noticed that I'm not wearing boots, and I'm not wearing sandals, and I don't have a cowboy hat. So I am not from Texas. I come from all the way from Missouri. So yay, Missouri, woo! That's actually the next part, woo, right? So anyone from Missouri? Yes? Hey, two people, that's twice as many as I was expecting. All right, so when I got here, I was meeting other people and I was saying, yeah, I'm from Missouri. And as one from Missouri does, people are like, oh yeah, Missouri, St. Louis. God, I love St. Louis, it's great. They've got baseball and an awesome hockey team and such arch, right? And yeah. But yeah, I'm not from St. Louis. So they're like, oh, Kansas City, yeah, City of Fountains, which I honestly don't even know if that's Kansas City. Google says it is. Why it's a city of fountains, I have no idea, but there are some fountains there apparently. And no, I'm not from Kansas City either. So they're like, oh, I've got their attention now because their list of cities in Missouri have now been exhausted. And I tell them, I'm from Columbia, of course. We got to talk. I don't know who you are. But he probably knows what I'm talking about because then the next comment is, oh, okay. Well, where's Columbia? I was like, oh, well, come on, Missouri, right? So we got Kansas in the west, Kansas City on the west, and we got St. Louis on the right, and in between then, we've got Columbia, right? We're that little dot there. And Columbia is well known for two things. One, the University of Missouri, who had an awesome, fantastic football season, better than any Texas team for sure. And come on up. So we're known for two things, right? University of Missouri, and we're known for being exactly in the middle of Kansas City and St. Louis. I'm convinced that we were founded because in wagon days, we were probably 2 days' time outside of St. Louis, and on the second day, you really just don't want to sleep in your wagon again, so we had to build a roof or something. So I tell people I'm from Columbia. That's how that goes. So I'm glad I got a little laughs there. And if anybody who doesn't find this slide hilarious, I'm really, really sorry that you don't find this funny. I laugh every time I see this internally. I don't know why. But if you don't find this funny, then just hunker down because you're in for a rough ride. So, random. This was just posted like an hour ago, and I know it's kind of cliche, but this is my first time presenting at a conference. It happens to be on a Friday, so it'd be really cool if everybody would stand up. I can take that funny little picture. Come on, no one's standing up. Oh, God. It's happening. Yay! All right, there we go. Yay, hugs, great. All right, they even got some woos for me. Woo is not really native to Missouri, but that's okay. So I'll post that picture in a little bit. I'm on me, CT Shryock. Go ahead and retweet that. I'll be really famous after that and somehow profit. So, I work for a company named Heroku. If you've heard of us, you know how awesome we are. If you have not heard of us, we do not make signs. We're actually a platform company. And in Missouri, that is really, really difficult to describe. I'm a support engineer at Heroku. And a lot of people think, oh, so you do support. Well, yes, I do. But at Heroku, a lot of support engineering is just like you. We're programming all day. But we have a specific mind of taking, all the support tickets we get and engineering ourselves out of support tickets. So specifically, I work with the Heroku Postgres team. where we are a database as a service for your favorite elephant-themed relational database. The team itself is less than 10 people. We have hundreds of Amazon servers, I guess. I don't know, we don't really pay attention. Thousands of Postgres databases, and just like the RTF team, we are internally referred by an acronym of DoD, which is Department of Data. And if you need to remember what that means, it just means we are way better than the RTF. Oh, M? I ruined that joke. Is Richard even here? He's not even here for me to make fun. There he is. Hi, Richard. Sorry, poking fun of you. So today, we're going to talk about the approach we take to managing lots and lots of databases in a talk I call Herding Elephants. Get it? Elephant, Postgres. Works out. So how Heroku uses Ruby to run the largest fleet of Postgres databases in the world. And the asterisk there means probably the largest. At the time of this writing, that's probably true. It might not be true for the next few years, who knows. Things change. It's not really a vanity metric we keep track of, but it sounds really cool on slides. Maybe you can tell I've never really spoken at a large conference. So when I got my little acceptance email, like you're probably thinking now, like, wow, what were they thinking with that? But so I had this title, just thinking, oh, herding elephants, this is going to be great, and I can come up with this whole talk that's all, oriented around, the Postgres elephant and elephants in general, right? But as I've discovered, talking to a couple people here while I've been here for the past few days, this is not a Postgres talk. Postgres is awesome, and we love it, and it's great. Well, I keep blocking the thing there. But no, I'm not actually going to talk about Postgres things, really. We could be managing, I don't know, whobots or something, whatever. It's really more of an architecture talk, right? It's about manage a lot of things in the cloud, things that we refer to as fleets, really. So it's about managing fleets, right? And who doesn't love Star Destroyers? Come on. No. You are a rebel scum. So, if you came here to hear important and cool things about managing Postgres, sorry. And so, I had this idea of herding elephants because it's thousands of Postgres databases, right? And I'll make this all elephant and herd themes, right? But it's also not a talk about elephants. So if you came here for elephants, sorry, I can't help you there. I told you we were going to have a lot of this. So quick backstory. Heroku Postgres is actually not a core thing of the Heroku platform itself. We're what's called an add-on. We exist in the add-on marketplace, which is a nice offering from Heroku to let you easily extend and add things to your applications. So like New Relic, Redis, and Postgres, you can attach these things as you will. So we were actually one of the first ones, which is cool. We kind of broke a lot of ground, broke a lot of things. And so I guess you can kind of think of it like this. Like you talk to Heroku, Heroku talks to us, and we're kind of in our own little realm, even though we actually all work for Heroku, and we all sit there, and we all eat the awesome lunches and stuff. And actually all of our applications run on Heroku, so that's pretty cool. Hold on, I have to fix something. I don't know what broke. Okay, something's... Now my timer's all messed up. I have no idea how long I've been going. So, Heroku Postgres, version 0, the very first thing, was just a single Sinatra application. It used a library called Stem to speak to AWS. Can you read the orange okay? Oh, so sorry. So I'll just read the orange parts. That's really disappointing. It looked great on my screen. So we use Stem to talk directly to AWS, and we use SQL to speak directly to Postgres. There weren't that many databases then, so this worked out great, right? We just had one app and one server, and they talked to each other. This all was great when you don't have a lot of databases. The goal or design motto or mantra we had was just the simplest thing that could possibly work, but no less. This is a common theme in the DoD. This is something they strive to do It's just something that's always in the back of our mind, right? More things, more features means more broken stuff. Every line of code you write to do anything is something that will bite you at some point. Or if you move on, it'll bite someone else, and then they won't like you. So fast forward to now, version latest. It's grown into a constellation of applications. About 5 some applications, still all using Sinatra. We're using Fog now to talk to AWS, and we still use SQL to talk to the Postgres instances themselves. And we've grown to use background workers, which is underlined horribly, with Sidekick and QClassic to do the bulk of our work, really. So now it kind of looks like this. This is nothing groundbreaking, right? It's a constellation of applications. They communicate over APIs. They have separation of concerns. So we have one that's just in charge of managing like the production tier, and one that's in charge of the starter tier. We got one that does your data clips things. You can probably count PG backups in there that does backups, snapshots. An internal one that used for administratively administering things, and other things like that. And some of them talk to AWS, some of them don't, but we've grown, we've spread out like that. And almost all of these applications are Sinatra running within Sinatra. So it's expanded. You know, we've got your various middleware, and you've got all your different endpoints that themselves really just launch individual Postgres Sinatra applications. By nesting Sinatra applications like this, it allows you to focus and to isolate, even within a single application, domain-specific things. And it makes code easier to reason about as it's separated into different endpoints. I butchered that one. And the apps themselves are divided into several processes. Anybody familiar with Heroku probably recognizes this. It's a proc file, and it's a way of taking a single application and defining individual processes that are contained in there. And this is a feature that you can then use and scale horizontally, because we can independently run like a bunch of different workers by adding a bunch of dynos that do that. And you can also see that 1, 2, 3, 4. This is just a summary. I've taken a lot, but the point is majority of these are workers. They are background things. The front end stuff is usually very quick, very small. It doesn't do much of the heavy lifting. That's all residing in the background workers. So applications end up looking like this, kind of this weird cell of things. You've got web, workers, clocks, and there's just a whole bunch of them. We literally run like hundreds and hundreds of workers. Across the 5 some applications, we have, I think, 50 distinct process types. And each application itself has maybe 3 or 4 web workers, and each of them has probably 200 plus workers of various kinds. Some of the queues or some of the processes themselves have 200 plus workers, right? So we use workers a lot. So even while splitting this into an ecosystem of applications, it's still the simplest thing that could possibly work, but no less. So that's kind of the ecosystem or the architecture of the lay of the land, so to speak. So on to managing databases. So like I said, we have this fleet, this great, awesome fleet of things. And in order to successfully run a service like this, you have to be continuously monitoring them. You have to keep watch of everything, right? So if you're probably looking at this and you're scanning each one, you got to be asking yourself, okay, well, what's wrong with this picture, right? It should jump out pretty quickly. You should be able to identify it from a service point of view quickly that it's this guy, right? We've got this whole fleet doing stuff, and then we've got this random one going the wrong direction. What's this guy doing, right? I mean, all of these ships coming this way, this is dangerous. This is no good. It's going to run into somebody. So you need to be able to monitor the fleet, and you need to be able to identify and spot this guy, find out what's going on, right? And when you manage and monitor a lot of things, you tend to expect them to go wrong. Just things go wrong. And you kind of have this attitude about it, right? So this guy, you need to be able to expect that this guy is going to happen. So he's doing his own thing. probably causing trouble. When you see things like this from a service point of view, somebody is probably having a bad time, right? That represents someone's servers or someone's database that's gone astray. If you don't keep your eye on these things, if you don't monitor them, things will go wrong. And people will open support tickets, right? Things go wrong, my database is down, and you can tell that people are mad. So how do you do that, right? You've got thousands of these things. How do you monitor them? How do you monitor them both at the server level, and how do you monitor them at like the resource level? I'll get to the resource in a minute. So your first thought might be, well, with these images that we're using, we'll install software on them that report back. That's not the approach they took. The approach they've taken is kind of outside in, right? So workers connect with SSH, and they collect information about the environment. The servers themselves are actually stupid. We try to keep them very dumb. They only have the base OS, which is Ubuntu 12 or whatever long-term support thing I think we had last. Postgres 9+, we've finally killed all Postgres 8s. We used to have those up until like 6 months ago. That was a pain. And this thing called Wally. Wally was something developed internally for shipping our write-ahead logs, which is a feature of Postgres. We ship that off-site. That's part of our durability, all that stuff. But Wally is written in Python, so if you came here for the Wally, we're not going to talk about that. So again, outside in. Information is gathered by the workers. It's used to determine the state. It makes an observation, and then by that, it decides the action to take. The primary things we observe here are resources. These things represent the databases. This has got things like information collected there is like database name, the port, created at, various database type information. And then we have servers. So servers represent the physical things on AWS or virtual things on AWS. You've got IP, it's instance ID, what availability it's in, how long it's been up, that kind of fun stuff. And we need to monitor these all the time. So to do this, we use two things which are awesome: state machines and stateless workers. I'll explain a little bit more on that. You probably know what a state machine is, though. The history there is it's rooted in game programming. Peter van Hardenberg is one of the founders of Heroku Postgres, and his background was in game development. So when it came to this kind of monitoring idea, he naturally thought of gaming, where you have this constant loop of observing your environment and taking action. Like, am I on fire? What should I do about that? Am I being attacked by a goblin? What should I do about that? Am I sleeping in a tent? Great. So, it's kind of like we connect to a server and we talk to it. We say, hello, and the server says hi. All right, well, that's established that we can connect to the server. We're making progress. And then we say things, all right, well, select one from Postgres. And it's like, oh, one. You're like, great. Now the server is not only up, but Postgres is running, right? So we do this all the time, forever, right? We've got thousands of resources, thousands of things that need to be checked, and every one of them gets checked at least once a minute, at least once a minute. So, you connect to another server. It has Postgres installed. Hi, hello. Select one. Then you connect to yet another server. Hello, hi, select one, great. All these workers going around, feeling the environment, thinking about things, and then maybe doing stuff. And we need to do this all the time. Forever, right? Okay. So to do this, skipped a step there. So to do this, we use a queue, but we treat it like a ring, because what we want to do is have a worker come, grab this database off the top of the queue, shift it off. We want to feel, which is a method name, and it sounds kind of odd when I stand up here and I talk about grabbing a resource and having it feel itself. And then we tell it to think, which is where we take action and we do stuff. And when we're done with that, we push it back onto the queue. We don't linger here. These steps are usually pretty quick. And we need to do this all the time. A lot. So we use state machines to help us out here, right? When you're creating a server or making a new database, we have different states that these things can be in. The creating stage, the happy up stage, the maybe stage, the whoops stage, and destroying and just completely dead. So we have these workers, and they need to go around, and they need to find out what state these things are in. They need to feel the environment, determine, am I up? Great, let's keep on going. Am I maybe up? Well, that was my last state, so maybe I'm up now. Maybe I'm back. I don't know. My last one was not so great. Maybe I'm down. Yeah. So, feeling. When we go and we connect to a server and we observe the environment, right? So, we have this class resource. This is obviously abbreviated. And we have this class called feeler. And the feelers really just collect the information about the system. So, when we grab the resource, oh, that's a lot of slides back. Okay. And we say feel. What we just do is we create a new observation with that feeler, and we grab the current environment, and we record that in the observations table, which is a append-only type table. We don't like keep an observation and update it. We create a new record each time, and so we kind of have a history. The observations are very simple. Just an ID, when it was created, attributes, which are that kind of stuff, and a foreign UUID, which points to the resource or the server that it came with, right? So we record that and we move on. We go to the next step, which is thinking, which is considering the last observation we made, what do we do, right? Well, we include this thing called, I thought I switched you slides. So resources have these things called states, right? And it's actually a method that comes from the stateful module. When the resource itself loads, we execute this method, and it's a name and it's a block of code. And we end up creating this map of things, right? So here's the stateful module summarized. So the state method takes a name, a default nil, which I have no idea what it does, and then we create like a map of names to blocks of code. So the uncertain one gets this block of code, and the available one gets that block, and so on and so forth. And here we get to the think method. After we've observed, we now just say, hey, evaluate the state that we're currently in. So look at this code and evaluate it. Do this thing. So if we're available, what do? Well, if the last observation we had said the service was not available, we transition to the uncertain stage. If it didn't say that, well, we just move on. Hooray. And just like if it's uncertain, if now it says it is true, well, we'll go back to available and get on with our lives. So, pulling something off of the queue, feeling its environment, thinking about it, pushing it back on the queue. And we need to do this all the time, forever. So, state machines, stateless workers. The workers don't know much about the state. They don't want to track the state because we don't want to tie up a worker to a resource. We want to be able to quickly just grab it, do something really quickly, and move on. We don't want a worker to have too much of an important relationship with what it's doing. Workers go down, all sorts of different things happen there, right? And workers are constantly going through the queue. They're the ones that do all the heavy lifting. They're the ones who do the things that take time. The stateless workers are the ones that talk to AWS. They're the ones that talk to the Heroku API to synchronize information or get commands or whatever they need to do. And they're the ones that connect to databases and talk directly to Postgres. These are the things that, as far as computer terms go, these are the things that take time. And then we need to offload them to background workers because all of these things require networks, right? And in a giant cloud, even a great one like Amazon, all of them can fail. And all of them do fail all the time. So part of the great thing of Amazon's network and the idea of quickly getting and doing this feeling and thinking and moving on part is if for some reason a worker can't connect to that service, it just immediately kind of moves on to the next thing, right? But due to the way Amazon's network happens, maybe that was just a little glitch. And then the next worker is going to spawn up some other place, maybe in some entirely other availability zone. It might have no problem at all connecting. So we've kind of avoided a false positive there. We've avoided and worked around maybe network partitions or various things like that could go wrong. Tired of you already. Sorry. So I was supposed to tie that in with the last thing. What to do when things fail, when we've figured out that it's not a network issue, when the server is itself actually really down. So if you look here, when that last observation, service available, is not true, then we need to go and we create an incident. And it's a certain type of incidents. We have a lot of these. So incidents, when things go wrong, because they will. So as I've said, on the cloud and at scale, strange things happen. I was talking to Tanner about this, about how as you scale, edge cases remain edge cases, but they actually just are kind of cases. Like you just become accustomed to them because you're doing things so many times that it's just not, it's not so weird or bizarre, it's just kind of strange and there. So we have all these different incident types, right? And this is just a summary. So we could have a resource down, stalls failed, followers are stuck, the mount drive is critical, server's down. Oh, did I duplicate that? Well, whatever. So in order to address all these things, naturally you start to develop playbooks, things that engineers can look at, read, and then use them to solve the problem. That way the solutions to these things aren't tied in an individual's head. So once you start codifying and cataloging all these things, you can create yet another state machine, right? So incidents have their own state machine. You can have a triggered one, resolved, waiting, I need a human, or resolving. Yeah, that was the other one. And so we bounce back and forth here, and we use the stateful module to do all this again, utilizing state machines and stateless workers. State machines, stateless workers. Take that home with you. And yet another queue, right? Another queue/ring of incidents. The workers go along, and we don't feel at this point, because at this point we know things are wrong. We just need to start taking action, right? We pop something off the queue, we need to take some action, and then we push it back on the queue. Maybe that action will actually resolve things. This worker won't know. This worker will just execute the code, transition to the stage it needs to, and move on, and then the next worker will pick it up and be like, hey, you're all better now. All right? So we need to do this all the time. A lot. All the time. So again, with our wonderful stateful module, we've got, and this is for incidents, right? So we've got trigger incident, right? All of these incidents are going to attempt this resolution, which I'll talk about resolvers in a minute. And if the resolution doesn't immediately work, we'll open a ticket to the customer. If we get an error somewhere in there, we'll escalate to human. We'll get to that in a minute. So same with await resolution. We've got one of these state blocks for basically everything that we saw earlier, all right? And we usually wrap these things explicitly in begin type statements because it's very common for these things just to completely bomb out if something's just unreachable. And as I said, if all else, escalate to a human. So actually looking at a different part of the file, we have all these types here, and it's an array. And we load all these resolvers. Now, these resolvers are files that we have codified from our playbooks. We've actually written it into code of how to do these things, right? So we load up all these files, and we create just an in-memory hash of them, of the type of thing the type of incident and the resolver that can handle it. We do that by calling the handles method, which should be on my next slide. Yes. So a resolver, like this is a basic restart one, and it can handle the resource down state. When the worker comes along, it's going to attempt to initiate the resolution here. It gets a lock on the resource in the database so that no other worker comes along and tries to do something to it. It sees that, oh, this is locked, I'm not going to try to touch this. And the first thing it does, in this case, is try to restart it. So it turns out on Amazon, if you're using elastic block storage and your thing crashes, if you restart it, your thing, in this case Postgres, is going to come up probably in the same availability zone, depending on how you have it configured, but on a different machine. And if you've used AWS long enough, or enough, you notice that sometimes just restarting the thing and having it come up somewhere else just completely resolves all your problems. So the very first thing we do is often just restart it, and everything sorts itself out. And then later along the line, we'll call resolved, right? So we'll perform a new observation, get a new state, and we'll do the tick method, which is actually an alias for the think method. Sorry. And so we'll kind of repeat the process. We'll continue to check these things, and transition to the right states along the state machine until we figure out things are better, until we think they get resolved. So here's another example of a resolver. This is for server down or for stuck EBS volumes. With a production tier, we might try to failover if you have a high availability failover. Yeah. Oh, this is for server too. So this will actually restart the entire server instead of the Postgres instance. That's when the thing will move. And we do another thing like resolve. Well, perform the observation. Is it available now? Does it still have a stuck EBS? Do something, whatever. Doing good. So, we've got these resolvers, but even that's not perfect, right? So we're left with the obvious question of what happens when even these resolutions fail? Because they will. So you saw there, right? When the resolver doesn't work, we have to escalate to a human. We actually have to call somebody, which is the software equivalent of, well, I tried. Eventually, it's all going to lead to Dumbledore there, which ultimately, we all know, leads to pager duty. Escalate to humans, we'll actually get somebody on the line, it'll wake somebody up, and then we have to go and figure out why the resolvers didn't work. Why am I being woken up in the night? Not me, fortunately. So, I have no idea how I'm on time, but I'm pretty close to the end. Oh, wow. That's like right on time. Odd. Summary of my mad rambling up here. The simplest thing that can work, right? The simplest thing you can do that works, but no less than that. State machines are fantastic for modeling complex behavior, complex states, things that can go wrong. Stateless workers are great because you don't get too tied up in what you're doing. You can have a lot of workers and you can quickly move to resolution, especially things that take time. And when you get big and you need to monitor things like that, expect things to break because they're going to break. And have a good attitude about it. Just remember, things break. Which is the summary of my talk there. Whelp. Whelp-driven presentations. All right, sorry, that was a mad rambling, but that's all I got. So thank you. All right. That's all I got.